My name is Cody Thomas. I'm the founder and owner of GlassRenu. We started the company 12 years ago to address the single most prevalent issue, I would say, that everybody under this roof deals with at some point on a daily or weekly basis, which is scratches on glass, okay? Whether you're a fabricator, whether you are a window or door fabric manufacturer, if you're a glazer, anyone who touches glass for a living is going to be surrounded by scratches throughout their entire career. And the age-old adage has always been, hey, if you can feel it with your fingernail, you gotta rework it. And today we're gonna be talking not just about how to fix that, but we're also going to uncover that rework really is just a euphemism for remake, okay? It sounds like it's a less expensive option, but really and truly, most of the times that you've got a scratched piece of glass, what do? You got to remake it, okay? That means we're going to be doubling costs. So we'll talk a little bit of the economics. Joining me up on stage, this is Andrew Chung. Andrew is our head of training and technical service liaison. He's going to be doing all the grinding today while I'm doing the talking. So that is what we're here to do today. Today we're going to take you through 4 different repairs while we're doing it, ranging from lightest to heaviest. At least heaviest within this industry. So we're going to start with metal rubs. We're then going to move on to glass and glass rubbing anytime 2 pieces of glass inadvertently collide. We're then going to go ahead and I don't know if you can see it, but we had the tempering folks over at TrueLight go ahead and put an extra thumbprint right in the center of the glass. We're going to talk about etching and how to get inadvertent etching or any kind of ceramic frit or other silk screened on stuff off. And then we're going to end with something that's probably not going to be too important for the fabricators, but more so for the glazers, which is rock damage. What happens and how do you take out when a piece of grit or a rock gets on that glass and scratches it up. So to start out, the first demo we're going to do is a metal rub. Andrew, if you could grab, what we've grabbed here is a hacksaw handle. It's made out of aluminum, same material as ladders and a lot of the racks that are around here. Bunch of our customers in the Midwest, we will run into this problem where glass will be going through some piece of machinery and a fastener comes loose, or a little bit of metal is sticking into the line, and as that glass is moving through the machine, it's getting a nice horizontal scratch right across edge to edge. And so by today, what we're going to try to do is show you how quickly we can get that out. Is this it right here? Okay, if anyone wants to come closer, I know it's kind of hard, or can you put something dark behind it, Andrew, so we can see it a little bit better? There you go. Okay, so that's an aluminum rub. You can feel it with your fingernail. It's definitely on there. Now with the metal rub, what we're really seeing is we're seeing bits of that metal be deposited onto the glass, okay? As much as we'd like to believe that the surface of glass is smooth, it's not, okay? Once you look at it under a microscope, you're gonna see hills and valleys, and aluminum is a soft metal, okay? It's going to leave little bits of it on there, and try as you might, sometimes you can clean it off, most of the time you're not going to. In order to take this off, we're going to use our least aggressive step, which is just our polishing compound. We've put Andrew's going to be putting just a few drops of polishing compound onto our felt wheel, and we're going to go. Now, what makes this polish different, or this step different than what you would buy from any one of the cerium or polish suppliers, is how we have manufactured this polishing compound. First of all, this is incredibly high-grade cerium oxide. It's 99.975% pure. We then mill it down and screen it into 4, well, sometimes 4, sometimes 5, depending on the application, but 4 micron sizes, and then we proportionately reconstitute that. And what that allows us to do is, in a single step, we can get our rough polish, our fine polish, and our ultra-fine polish without having to go through multiple steps. At this point, we're 30 seconds in, and the damage is out. So now, I said we could fix it, never said we could clean it. There you go. If you want to put the towel or something behind, so because right now it's got a white backdrop. So the scratch is gone, and if anyone wants to come up and take a look, feel free at any point. Also, just as a quick side note, We are in booth 2163, and we're going to be doing demos nonstop there. So after this show, if you'd like to see a more up-close and personal demo, want to ask any questions, please feel free to stop by booth 2163 and ask away. So there we have it, metal rubs, 30 seconds. We used a total of about 35 cents worth of polish on that process, 30 seconds of manpower. That right there is how you recapture that glass instead of having to remake it or rework it. For the next piece of damage that we're gonna talk is probably the most common type of damage that I see when I'm walking into fabrication plants on a daily basis, which is that of incidental glass-on-glass rubbing. As much as we'd like to believe that everyone who works in the facilities are always super careful, accidents happen. And it happens whether you're moving the glass by hand, stacking it, but it also happens when glass is getting loaded and unloaded from automated machines. Every now and then, two pieces of glass are going to rub. So if you go ahead and put some, and then could you put something again just behind it so we can, does that white background, let's see, does that, use the hat, the darker. Look at that, right? There we go. Okay, pull it back a little bit from it so we get, yep, there, okay. Did everybody see those scratches? Okay. And just because Andrew's gloved up, yeah, I can get my fingernail in this one and that one, no problem. So glass-on-glass scratch has always been considered to be somewhat of a fatal or terminal bit of damage. Okay, once two pieces of glass have rubbed together, yeah, you might be able to, if the piece of glass is expensive enough, or if it's a large format piece of glass, you might turn loose a guy with a rabbit and some cerium, and he may try polishing it, and 45 minutes later, most of it's gone, but there's still a little bit there, and depending on where it is and placement and what spec you're building to is going to determine on whether or not you can ship that piece of glass. What we're going to show now is Andrew's going to start out, we're going to go one step more aggressive than just the polish, and we're going to actually use our disc, what we call our pre-polishing disc. Andrew's going to set the grinder at a speed of 1800 RPMs, put the disc flat onto the glass, and start grinding. And what we're going to notice is that very quickly we're going to hone the surface of that glass down to the bottom of the damage. Now there are a couple of things that you're looking at right now and you might be wondering, okay, first of all, we did not invent scratch removal. People have been trying to remove scratches from glass as long as people have been using glass as a building material, okay? But what we did invent and what we did pioneer is dry grinding on glass, okay? Anytime you use water or a coolant as a lubricant when you're doing scratch removal, you run the risk of creating optic distortion. And really what you're going to do is you're going to create a lens in the surface of the glass. There's nothing you can do to prevent that, because the reality is water is a non-compressible medium, and when you put it between a stationary plane and a rotating plane, well, let me ask you, who here's ridden a bicycle when they were a kid in the rain? What happens? You get a rooster tail up your back if you don't have a fender on it, right? Same thing's going to happen when you're grinding. First of all, you're going to eject fluid everywhere. And secondly, at any inertial moment, the bulk of the fluid between the disc and the glass is going to be in the outer 1/3. By doing it dry, what we're able to do is maintain an even grinding surface across the entire diameter of the disc. You just heard Andrew turn the speed up right now, and you'll notice the disc went from looking gray to becoming white, all right? What that is the glass dust. It's if you cut wood, you get sawdust. If you cut glass or grind glass, you're going to get glass dust. But our discs are designed to trap greater than 98% of the dust that is created. And we do that specifically for this reason. In order to cut glass or polish glass, you have to use a tool or a medium that is as hard as glass or harder. While that dust is very fine, averaging around 10 to 15 microns per particle, it is still as hard as glass, okay? So when he turned the speed up, what we were doing is we were actually using that glass dust to start the polishing process, and that lightened the haze. Now, if you look right now, you'll see it doesn't really show up too well when you got a white background, but you can kind of see there's a light haze around the area where Andrew was working. What we're going to do now is we switch back to the polishing felt. Put a few drops of polish. The goal here is, again, this is the only time we're using any liquid in the process, and the reason we're using liquid is a carrier medium to deposit the cerium compound that we're using onto the felt to allow us now to polish. As he begins polishing, you can see we don't want it wet enough that it's going to eject in any direction. We're not looking to create a mess. And realistically, the only polish that is ever going to be used is the polish that's existing between the felt and the glass, right? So if you put so much on that it's running down the glass, all you're doing is wasting polish. At this point, the glass is clear. Our general rule of thumb is polish till you think you're done, and then polish one more time. As you can see, for the damage that we did, the damage is just about out. He's still polishing away. All right, that's fine. The whole point on this is we're going to spend less than 5 minutes doing the entire process start to finish, okay? And that's where it's going to come into the economics calculation on the types of glass you're working on. Whether it's Arizona shower or a shower door, Arizona shower door boys are here over there, and I know I don't think they'd mind us sharing that they've been using us now for quite some time, as well as a number of other fabricators. But when they run into it, you've got a shower door and it's got a little errant scratch. Rather than having to go back, remake it, add another day, potentially 2, possibly, to getting that glass ready to go, you're able to address the issue directly at at your QA department prior to loading it onto the truck and still make the same shipping time out. So at this point, the damage is out. We're back to clear glass. And so now what we're going to do is we're going to go one step further. As you can see, we pointed out here in the center of the glass, we have an extra tempering stamp, tempering thumbprint. We work with a lot of companies, not only pretty much I'm sure everyone here on some level works with tempered glass, but we also work with a lot of companies that silk screen onto the surface of glass, whether it is a ceramic frit that is used for a glue point, for windows and doors that are ending up in maritime or recreational vehicles, to glass that's going to have different designs or stuff etched onto it or printed onto it, silk screened onto it. So in order to take out something, once we've used either a hydrofluoric acid or a sandblast damage to etch something in, we have to go a little bit more aggressive. So for this step, Andrew's going to start out with what we call our black disc, which is kind of the middle grade, but probably the most aggressive that anyone in this industry would ever need to use. We're going to set the speed at 1800 RPM again, and Andrew, if you please. Put it right on the center and turn it on. So one of the most common questions people ask me is, okay, Cody, so we're grinding on the glass. What is happening to the glass when you're doing this? What are we doing? Okay, well, obviously, first of all, we're sanding the surface of the glass down, no different than you would a piece of wood, okay, that had a gouge in it. You'd start with an aggressive sandpaper and go through several successions until you got the surface ready for whatever, whether it's a polyurethane or varnish or whatever, and then get it to that final finish. What separates our system from a lot of the other systems that have tried to do this is we've developed an abrasive that allows us not only to do everything dry and in the absence of water so that we're maintaining the parallel nature, but the way that the disc degrades as we're using it is very predictable and very consistent. And what that means is if we start out with a disc that comes in at a grit range of, let's say, 180 grit, by the time we're ready to jump to the next one, it is now worn down to closer to something around a 320 grit. So you're able to get multiple steps with the same disc, which then, again, cuts down the time. And that's just the nature of the abrasive that we are using. The next question in terms of what are we doing to the glass has to do with thermal issues, okay? Obviously, we're dry grinding, and anytime you apply friction to any media, in the absence of some kind of coolant, you're going to heat it up. The general rule of thumb is that as long as you can keep from the hottest point of the glass to the coldest point of the glass, no greater than an 80 degree Fahrenheit differential, you're not going to have any issues with that piece of glass. And that transcends not just tempered, but also with annealed glass, and more importantly, when you're dealing with laminated glass. Laminated glass obviously has that internal divider, and as you're heating up the glass, you don't want to create too much of a heat spike. The beautiful part is our abrasives are aggressive enough that they allow us to get in and get out before the glass has a chance to get hot enough to do that. That's another reason why you're seeing Andrew jump from one point to another point on the glass rather than doing all the same repairs in the same spot. Andrew's back to the pre-polish now. You see that nice white buildup, staying flat and running it around. Notice he turned the speed up again. That's so that we can use that glass dust to start the polishing process. At this point, the damage is out, the haze is uniform, and now we're going to switch back to the polishing felt so that we can get that glass back to crystal clear. One of the technical questions that I was asked earlier today, and I think it's a very important question because it comes to bear when the fact that we are dealing with tempered glass, and we do a lot of work with tempered glass, is what happens to the tensile strength of the glass after we've repaired it? Because after all, he is shaving about 1/1000 of an inch off, and we know that the tempering envelope is on the outer part of the glass. The good news is that we have done extensive testing, and we have found that even though we are removing that outer little bit of glass, that outer 1/1000th of the glass, we are not encroaching into the tempering envelope enough to make any difference. And as long as we're doing one repair, which most of you would be doing a single repair on a piece of glass, and when I say single repair, I mean single repair in one area. You may have 3 scratches, but you're not doing multiple grinds in the same area 3 times, okay? As long as you're doing that, when you shatter the piece of glass, should the piece of glass shatter, you're going to get identical popcorn sizes between a brand new piece of glass that's never been worked on versus a piece that has been repaired. And the tensile strength difference is negligibly different. It's less than 0.1% weaker. So by all standards, it's absolutely fine. There we go, polishing it out. Now it's time to clean it up, but there we have it, okay? Less than 5 minutes and from start to finish, and we were able to take that stamp out. Oddly enough, it's interesting, a funny story about the etching. We had a company, an auto dealership actually in Chicago, had hired a gentleman to come in and etch VIN numbers on the windows of the cars, and they were only supposed to do it on the windscreen. But the guys went ahead and etched it on every single window on every single car, and they were looking at well over $500,000 to replace all the glass. We were able to help them out. They were able to get it in, and they did the job themselves within just over a week, and spent a total of less than $500 on materials. So that's where you can see now if we can start recovering this glass rather than having to reworking it or remaking it, because again, rework is just a euphemism for remaking, okay? It's amazing the transformative effect that this can have on a bottom line. Those are the most common types of damage that a fabricator, an OEM, a window door company are going to run into. But now we're going to go a little bit more aggressive here, and we're going to go ahead and put on some rock damage. One of the things, I got into this business because my brother was a contractor, and he had a stucco subcontractor come and get stucco on every single window on 80 homes. And then when they tried to remove it, they were not very careful, and they ended up scratching every single panel. That was what got me into this. And so, you know, looking at job sites around the country, and that's really where all of the windows and doors you guys are building, they're going to go to a job site. And I've never been to a job site where the glass showed up on the day it was going to get glazed. It usually shows up anywhere from a few days to a few weeks before it gets installed into the building. What happens? Well, it shows up, and the GC or someone says, okay, just stack it over there. Or, hey, you know, put it over here, and then they kind of forget about it for a couple of weeks until the glazer comes and he's getting ready to put it, and by the time he gets there, it's covered in a layer of filth. There have been rocks and gravel pushed up against it. There's all kinds of incidental damage, and ultimately then the glazer is, you know, he's the one that the short stick gets pointed at and says, oh, well, you messed this up, you got to fix it. What we're going to put in now, we've got just a rock. We're going to go ahead, Andrew's going to put in, grab a good rock. There we go. All right. And if you put something behind it, there we go, we can see. up there. We can see that. All right. Rock damage is very similar to the etching or to the glass damage, but because depending on the type of rock that is creating the damage, it can be very, very deep. And I've seen rock damage where you've actually got chips and flecks of glass coming out. So in order to get that out, we're going to go back to the black disc, which was our more aggressive disc, and put it back on the surface at 1800 RPM, fire that bad boy up, and take it out. At this point, the damage is out. So now the process is going to be the same from this point forward, okay? We're going to go from the grinding to the pre-polish to the polish. So it's a simple three-step process. And while Andrew's doing that, what I'd like to do is I'm going to talk to you a little bit about the economics of glass restoration and how it can really affect your business and really add value to it, okay? A wiser man than I once said that there are only three ways you can create value. Okay, you can either create value because you're going to do something for a lower cost, you can create value because you're going to do something faster, or you can create value because you're going to create a better quality end result, right? But those are the only three ways you can create value. And in my barber shop, they've got a thing up there and it says speed, price, or quality, pick any two, right? I think we've all heard that at some point. Let's talk about the cost. Obviously, if we're working on a 6-inch by 9-inch single pane, 3/32 piece of glass, whether it's tempered or not, there's probably never going to be anything that you could do to that that's going to be cheaper than just remaking it should you have a problem, okay? So I'm not here to tell you that this is going to solve every single problem, because it isn't, all right? There's a lot of glass that you guys are going to fabricate during your daily basis that it isn't going to make economic sense. But once you start getting into a point where the fabricated cost, right, the material plus the labor and everything you're putting into it is over $6. That's it. If you're spending more than $6 manufacturing a piece of glass, all of a sudden this now becomes very cost effective, okay? The total in what we've done to do all these repairs today, we've used less than $6 in materials. That's 4 repairs for $6, and theoretically, if that was on 4 different panels and each one of those had a cost, whether you're talking about a shower door enclosure, you're talking about a large format slider or a picture window, really doesn't matter, okay? As long as that piece of glass is costing you more than $6 before you ship it out, all right? And that's not even including freight costs and other stuff like that. It's going to be a net positive for you to use the system. When it comes to time, obviously, if you're going to have to remake every piece of glass that has a scratch, depending on how many operations have been done to that piece of glass, that's going to take time. And that can push not only delivery schedules, but the more important, and I think I heard Beth talking about it, where they're talking about cash flow, that's where it's going to hit you the worst. Because we can't invoice for something until it's delivered. So if we've got to remake something, and if we're not figuring that out until after it's been shipped to the customer, if we've got to ship it back to rework on it, or if we just have to remake it and ship it a second time, not only are we incurring the costs of all of that extra activity, but we're also incurring the cost of capital, right? Because we're not getting that cash flow, and we got to find other ways to finance the business. Additionally, it's important to note that a delay at fabrication or in the manufacturing ripples through the GC's schedule, right? They may say, okay, we need the glass at the job site by X date so that the glazers can start the next day. If that pushes, they may not be able to get those glazers back for a week or 2 weeks. So it's like a pebble in a pond. You get those ripple effect as it goes through. The third way is quality. And we work with a lot of fabricators who, before implementing us, there were a lot of their customers lamented the fact that they were buying their glass from them because they knew some percentage of every crate of glass that was going to be delivered. They just expected that there were going to be a couple of scratches, and we're going to have to reject 5% or 10% of the glass when it comes from fabricator A, because that's just what we've come to learn. And then as soon as they started implementing this process, it was, their customers were like, wait a minute, what happened? what you guys do. The glass looks great. How's that going? So from a quality standpoint, this gives you more control over the perceived quality of the product that you are putting out every single day. Reworking and remaking are always going to be the most expensive, but recovering is where you're going to save the most money. At this point, Andrew's going to go ahead and clean it up, and the rock damage is no more. These are the types of damage you guys run into, but to give you an idea of the limitations of the system, I have yet to come across. Now, as long as the glass is not cracked or broken, I can fix it. I've taken welding slag out of glass. I've taken sandblast damage out of glass. I've taken 40 years of seawater etching, where I was shocked that there was actually glass underneath the crustiness that was on that window, okay? You can take just about any type of damage off so long as the glass is not cracked or broken. That is pretty much what we have for our live demo today. I'd like to open it up. If anyone's got any questions, please feel free to come up and talk to me. My sales manager, John, is over here. John, if you'd raise your hand. If anyone has any questions, you can also talk to him. We're going to be in booth, or we are in booth 2163. I'd love to invite all of you back for a more up-close and personal demo. If you have any questions or concerns otherwise, my name's Cody Thomas. We're with GlassRenu. Thanks so much for coming.